Good afternoon. Good afternoon. Good afternoon. The grade 12s, Eastern Cape. Greetings once more. In this session of mathematical literacy, this is still Mr. Chabalala of last week. Today I'm going to be with you for the second time in this beautiful and wonderful subject, mathematical literacy. I hope you're doing well at your schools. You are busy preparing yourself for the upcoming prep examination. And if you haven't done well during the June examination, this is the time for you to redeem yourself and to ensure that you are ready for the final examination. Remember, the prep exam is going to be the last leg where you have to size yourself and measure your ability in terms of passing a metric. But I trust you because you are working very hard. And I know that you're going to do well. Am I right? I hope so. That come September and or October, when you come back, the results that you get, it will be good. And remember, it's very important to take this coming examination serious. Because some of the institutions, they are also using the prep examination results for the admission at their institutions. So it's very, very important that you put the weight behind that. And remember that it's a full paper. It's exactly the same as the final examination, where you have 150 for paper 1 and 150 for paper 2. And the format is exactly the same. So if you are doing well in this prep exam, the chances are very high that you're going to do well also in the final examination that will be written in October, November. Thank you very much. Today we are going to focus. Remember, last week we're focusing on finance, and we dealt with loans, investments, for the stuff. And I hope you enjoyed that session. And I told you that finance is also one of the topics that is having more weight in our examination. Now, today, I'm coming with another topic that is also having more weight, which is measurement. But we are going to focus on the smaller part of that, which is models. In brackets, you can see Mr. Chabalala wrote packaging, which is very important because when we say model, it's a bit like abstract. It's more mathematical. But when I put packaging, I show you that we are going to model for the sake of packaging. All right, let's continue. I hope you are ready. You see, I've got even pictures here. It's very important that you, for each and every topic that you deal with in maths, how do you relate it to real life? Because our subject is alive. It's that subject that I love so much because I can attach what I did in the classroom as I go outside. So you see people when you see a truck passing by, loading different goods. There is a stage where that truck was sitting at them or was standing at what you call a big industry, whatever, or a company, and they were loading the stuff, different items, boxes. It can be cans, it can be steel and all the stuff. There must be a person who is doing a planning as to how are we going to package these items in this particular truck before it leaves. And the company will maximize the number of items. Maybe one of you will be working for this company and you'll be working on that side of the sales department, and you'll be responsible for this logistics. And you are the one who's going to do the calculations and tell the people who are loading that I've already calculated that this truck that is standing here is going to take 10,000 boxes to another destination, which shall be at the shops or whatever. And why are you doing that? You do it in such a way that you maximize, because you want to work in such a way that you become cost effective, you save money for the company, but you ensure that even if you are saving, you are transporting as many boxes as possible, because you can't afford to have a lot of trips. That will be costing a company. So you can see it is important that you understand why packaging in mathematical literacy. Even in our real life, even in your house, the way you pack things in your wardrobe, the way you pack things in your clothes area and all that stuff, it's very important that you consider the issue of modeling it in such a way that you can pack effectively so. All right. Hence, the topic is all about packaging. And remember, this topic is now in this term. I think you are done with your teacher on this topic. Mr. Chawalala is not going to start afresh. We are just doing a revision. So I'm just reminding you because your teacher has already taught you. Am I right? Yes. Yes. No, for you. Yeah. No. So what I'm saying is that for term 3, remember for term 3, you are dealing with plans, elevation plans. You are dealing with the assembly diagrams. You are dealing also with the models, which is packaging, the ones that we are doing here. So term 3 is very short and it has only few topics. And this is one of the topics that you must also get marks. It is very important that you go to the exam understanding exactly what it's all about, packaging. Now we are continuing. That is what is packaging. I've already given you the practical part of it. We call it an application. Where do we apply it in real life? The content. That's the beauty of mathematical literacy. Huh? Whatever we are doing, yes, we are part of mathematics, but our mathematics is going to be what is informed by the need in a real life situation. And we are doing mathematics in order to make informed decision. That now that I've calculated this, where am I going to use it? How is it going to benefit me, this calculation? So if you can approach math lit in that way, you'll pass. Don't divorce it from outside world. Now, packaging. Packaging is the process of finding best possible solutions to pack items. That's what Mr. Chawalalas alluded to earlier. You remember, how best can I put this 1,000 box in this panel van? You see that second picture, those two ladies there, they are packing inside a panel van. They will try to fit as many as possible because they've already modeled it as to how many can fit there. It further says problems involving design optimization, finding maximum or minimum. So this is what is all about packaging. Remember, I said to you, in this case, if you are packing, you want to pack as many as possible with the minimum costs in such a way that you save, but you maximize the number of items that you are packing. That's why we are coming with the word optimization. Shall I was supposed to have written S there at Z because in South Africa we don't use Z most of the time. But it's fine. It's not a problem. It's a language issue. Optimizing space, finding the most effective way to pack items. Mr. Chabalala was trying to explain what is all about optimizing. So optimizing is finding the most efficient way To pack, remember, it's all about packaging. To pack items and minimizing waste and costs. You see where that minimum comes from. Yeah, maximizing in terms of packing, you are minimizing in terms of the cost. Nice one, yeah? Cost effectiveness of packaging materials and containers. I've already said that. Right, let's continue. It further involves dimensions of shape, such as lengths, very important. You see, this is in bold. Length, width, height. What is the other word for width? Breadth. Don't forget, we use these two words interchangeably. So if you don't want to say breadth, you can say width. So don't be confused. Right. Even we are going to consider the diameter, the radius, etc. Meaning that now, as much as packaging you find it in real life, I said to you, in mathematical literacy, we have maths, or we have mathematical concepts. But we ensure that these mathematical concepts, we apply them in real life, or they help us to take decisions. Now, the moment you talk about the length, the width, the height, the diameter, now you remember there comes the issue of the areas, the volumes, etc., etc. So that is math, but you need to know it. That's why our subject is called mathematical literacy. Mathematics is there, but we are becoming literate in using mathematics. Now, take note that we are going to deal with shapes, different types such as rectangular prism. Some of them you learn them as early as grade 8, even grade 7. So under rectangular, what you call boxes, calculating area, surface area, volume, etc. But you'll see, when we are dealing with packaging, most of the time we will shy away using the area, the volumes, etc. But we'll be using the length, the width, and the height more. But I was just showing you that this is part also of what we can use. Cylinders, still under the shapes. When we are dealing with cylinders, we are focusing also on that I've already alluded to, even how much material are we going to need. Finding the most efficient, right? It is just repeating what is optimization, cost calculation, because there is no way that you can deal with packaging without any cost. It is money for the truck to come and fetch those boxes. And at times they charge the company according to the quantity. And they will say, oh, you want us to transport 1,000 boxes. So we are charging one box of this item. We are charging you 150. So you'll have to multiply 150 by what you call 1,000, etc. So there is issue of money. That's why we are talking about cost calculations. All right. Okay. Just a picture there of a 3-dimension shape or an object. Now, what must you know when you are dealing with packaging? Very important. 2-dimensional and 3-dimensional models. In this case, we have a 3D object or model. But in the same 3 dimension, we can have a part which is a 2D. Let's just remind each other. What is a 2D? 2, 3. Yes, yes, you are right, Luvuyo. You are right. I can hear you saying, no, Mr. Chabalala, it's all about when you talk about two-dimensional, we are focusing on area, meaning that we are going to have only two what you call dimensions, and those dimensions can be length and breadth or whatever. Yes, it's good. So, but when you talk about a two-dimensional object, that's where an object or a space where you can see only two dimensions. If you take the front part of this object, or you extract it from there, it's going to look like this. Mr. Chavalala, via your hands. You can't draw a straight line, right? Let me try. Okay. We abstract, we take it out. So we say that it's just the front view of this object. We can see only two dimensions. Which are those two dimensions? This is a rectangle, we agree. It's a rectangle, and you can see which two dimensions. Yes, you are right. You can see the length, you can see the breadth or the width. So we say this is a two-dimension. What are the examples of a two-dimensional shape? Yes, that paper that's sitting on the table in front of you. The top of that table is a two-dimension because you can see only two dimensions, the length and the breadth. Yes. Even a rectangle, it's a two-dimension. When you draw it like this, yes, it is this side and this side. It can be a rectangle, it can be a square, it can be a still two dimension, S by S. And when we are calculating the area here, it's S multiplied by S is S squared. And if it was centimeters, it will be centimeter multiplied by centimeter. It will be equals to, your answer will be square centimeters. If it is 5 here and 5 here, it's gonna be 5 by 5. Don't confuse 5s with S's. It is 25 centimeters squared. For the sake that your answer comes out as squared or 2, there, your exponent is 2. That's where two-dimensional comes from. It's the same. The same with the rectangle. If it is this side is 10 millimeters, and this side, the breadth, it is 5 millimeters. What will be the area? The area will be length multiplied by breadth, which will be equals to 10 multiplied by 5. We're going straight because the units are the same. You don't have to convert. The answer, it is 50. It's millimeter here, it's millimeter here, 50 millimeter or square millimeter. Still have square, it is two dimension. But if we take everything, what is this box as it is, the whole box, what do we call it? The rectangular prism. You are right. We are saying this is a three-dimension shape or a three-dimensional object. Why? Yes, you are correct. 3 sides. 1, 2, 3. You can see 3 sides. And here you can calculate volume. And what is the volume of the rectangular prism? Yes, right. Length multiplied by breadth multiplied by height. This case, Let's say your length is given as 12. And here your width is given as 5. Your width is given as 5. Let's make it centimeters. Centimeters, 5 centimeters. Your height, let's make it 6. 6 centimeters. Mr. Chawalala must be neat. Right, eraser. Good. It's gonna be 6 centimeters. To calculate the volume now, we are going to say length multiplied by breadth multiplied by height is going to be 12 by breadth, which is 5. 12 multiplied by 5 already is how much? Is it 60? Yes, it's 60. Multiply by how much? By 6. What will be the answer? 60 multiplied by 6. 60 multiplied by 6 is going to be 360. Am I right? Can check me. Remember, centimeter, 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 6 centimeters. But what we're interested in, we were only interested in the what? In this, which is the 3. That 3 goes with 3, this one, 3-dimensional. All right, in a nutshell, I was just reminding you about 2-dimensional and 3-dimensional. They are very important in measurement, not only in packaging, in measurement as a whole. That's why I took 5 minutes to remind you what is all about 3-dimension and 2-dimensional. I hope you remember now where the word does come from. Remember, this can be given also under the terminology. We have that question of terminology that comes here in and here out. Every question paper will say to you, define the word 2-dimensional shape or object. So you must know it. You must know it. Very important. Now let's continue. Now, if we continue, you say this packaging, for you to understand it well, you must also know how to use a calculation, use of calculation, the most cost-effective and most appropriate way to package boxes for optimal use of space. We have mentioned that in the previous slide, that is what is all about it. So you must have a skill of how I do it, how are you doing that? This is exactly what we are going to do today. And the next one says use different packaging arrangement. You'll see here we've got 2 different packaging arrangement, but there is only one that is more recommended for in mathematical literacy. We'll talk about this what you call 2 methods of packaging or arranging. Okay? Understand the different packaging arrangement, determine quantities of materials used for different packaging arrangement. Very important. Okay. Furthermore, now we come to methods of packaging. I spoke about it. Okay? Practical method using 2 diagram or 3 dimensions of the scenario. How many box can fit into a space using, very important, length, breadth, height, and diameters. That is what you call practical method. And remember what I said initially. I said mathematical literacy is all about real life, practical application of what we have learned in a classroom situation. When you are busy dealing with this topic, you are preparing yourself for that track that is coming to tell the workers that you must pack so many boxes in this track. Or this is the company that is producing the, what do you call, the tin fish or canned stuff or canned food. These cans must be packed into boxes and be transported to different destinations, or they're going to sell them in boxes. You see them being packed in a wholesale at Macro, at ShopRite, whatever. There is a method of packing. And in mathematical literacy, for the sake of assessment, in the question, examination, you must master this method. We call it the practical method, where you are using the length, you are using the breadth, the height, and the diameter to pack or to model. Right. This is my friend Peter, a very passionate guy about maths lit. Yeah, Peter Templeton. Here he was demonstrating how can you pack cell phones in a box. This is what we are saying. He's modeling it. It's not doing calculation. He's trying to check practically as to how can I put them. And you can see here that a cell phone has a length, it has a breadth also. And this box also have a length. Remember, it's a 3D shape. It also has a height. Remember, the cell phone also have a smaller than a height there also. It's a 3D shape. Now, this box has a length, has a height. It also has a breadth. L, H. The same with the cell phone. Huh? What is happening here? You can see that he's putting the length of the cell phone along the length of the box. He's using the practical method where you are using the length. And you can see also the height, the breadth. The breadth of the cell phone, it is packed along the breadth of the box. Nice one. The height of the cell phone, it is packed along the height of the box. So we are going to come up with some examples to make this to be more understandable. So can you understand what we mean by the practical example or method of packing? This one, we call it mathematical method, using volume over volume, where you can calculate the volume of a cell phone, if this is the cell phone, and take the volume of the box and divide this one by this one and see how many can fit inside. But in mathematical literacy, this method is not recommended and you won't get marks. I think even if you can get marks, you can get 20% of your marks. If your question is 8 marks for this question and you use this mathematical method, you might get even 2 out of 8. But if you are using the practical method, you'll get 8 out of 8 if your answer is correct. Do you understand? But we don't dispute the fact that there is this method of mathematical method Why, Mr. Chabalala, are you recommending this one? This one is more practical. And the results of this model often are what? True and realistic. Remember, we need accuracy. You're working for this company. Your boss is not gonna take a no and say, no, I had to use the volume of the volume. That's why I could not pack this. Then and said, no. I employed you. You come from school. You did math lead. Don't come with stories. You should have seen that the practical method is the one that will make us to be cost effective. Remember, we are dealing with costs here. Then all of a sudden, you are fired. You are fired. Because you could not save for the company. You could not, try to maximize the number of items that to be delivered whilst you are saving for the company. You see? You need to understand, have a conceptual understanding of an aspect before you go and write the examination. It's not all about just, I know that I must do that calculation. Because if you don't have basic understanding like now I'm doing, it's like I'm wasting time. No, I'm not wasting time. I'm giving you the basics in such a way that whenever you come across any questions, remember the examiners are changing questions year in and year out. And the only thing that you can do to answer any question that comes in any different form is to have what you call basic conceptual understanding. Understand the concept. How, Mr. Chabalala, in a practical manner of Peter Templeton. You understand? Because when you see the question and you feel like, hey, I don't know where to start, then you remember that box. You remember that cell phone. And you remember that guy who was putting a smile on his face when he was modeling how to pack the cell phones in a box. He say, this one, I'm going to get it. This 8 marks, it's mine. Yeah, this is mine. I want you to have that mentality as you enter the classroom. That walk, that must show the confidence that come whatever question, I'm going to maximize the marks that I'm going to get because I'm ready. I listened to Mr. Chawalala when he was presenting about the packaging and the models. I listened to Mr. Chawalala when he was talking about finance and other topics, exchange rate, whatever. So confidence is very important. And when you finish your exam, after 3 hours, you say, what's my name? Then you do your calculation and add the marks and find that, wow, out of 150, I've got 140 or 145, even 150 out of 155, because you were ready. Yeah, score. Okay, I think you understood that most of the time we are going to use, or always we are going to use the practical method of what? Of packaging or modeling. Let's continue. Right? Done a lot of mess here. Cannot see what is happening. Right? Sorry for that. Time. I can't continue with this ink on top of that. You see, in this case, it is packing a cell phone inside a box. This cell phone is a rectangular prism. It's a rectangular prism cell phone because it has a height, it has a breadth and a length. The same with the box, I guess we spoke about it. The same with the box. So it's a rectangular prism vis-a-vis what? Rectangular prism. Packaging can also, inside the same box, you can change and say, I'm not going to pack the cell phone this time. Remember, I said one company will be transporting the cans. If it is the cans, it means that now inside a box, a rectangular prism, you are going to pack what? In mathematical language, a cylinder. Yes, this is a cylinder. Thank you very much, Nosipo. Thank you very much. This is a rectangular prism. So when you are modeling, you can model in such a way that how many cans can fit inside the box. Meaning that here it's a rectangular prism vis-a-vis what? Yes, a cylinder. And this is an illustration. Here is a rectangular prism. Here is a cylinder. Am I going to pack them along this way, or I'm going to twist it so that it is like this? So you model it. But remember, you must be cost effective and you must maximize your package at the same time. So it is very important that you take consideration of that. So it means that don't be confined or practice only the exercises or the activities where you are dealing with rectangle versus rectangle. No, or square over square, or rectangle over what you call square. Or yeah, no, you need to also consider that you can have a circular what you call or a cylinder inside the rectangular prism, which is a box. Even the triangles. We have other things that are in a triangular shape. They need to be packed. They need to be packaged. So you can find yourself also having an answer where you are modeling the what you call the packing of triangular shapes into a rectangular prism. Meaning that you are going to do what now? You are going to, it's going to be, in that case, is going to be a what? A rectangular prism vis-a-vis the what? The triangular prism or whatever, what you call a 3D shape, a triangular prism. So in this case, it's going to be triangle, rectangle. So those are the ones that you must remember. We don't spot. We are ready for any question that can come. We don't cram. Right. Still on the packaging. Let me put all of them here for the sake of time. Mathematical calculations are necessary to solve these problems. Mr. Chabalala has already alluded to that. You remember, I cannot overemphasize more than that. Remember, Mathlit, unfortunately, we don't rush to calculations. First of all, we must make sense of the topic that we are going to, to deal with and have an understanding. That's why it's a lot of writing, lot of talking. Because out of this, again, terminology questions will also do that. How to do, yes, we've got a question here that says how to determine the number of items that will fill in the box. This is what we are going to do. Remember, I said to you, I'm giving you only the first, the basic understanding and the principles that we are going to use. Then we are going to have examples now where we are going to determine the number of items to fill a certain box. Don't worry. Thank you very much for that question. You can see that you are ready. Now, mathematical calculations are necessary to solve these problems. When looking at the objects that could fit in a certain space, This is what the question is saying now. How many can fit in that space? Rounding down, rounding what? Rounding down, it's important. Very necessary. As rounding up will result in objects not fitting in a space. My honorable grade 12s, boys and girls, I'm saying to you, in mathematical literacy, we have this concept of rounding. Concept of what? Rounding. You must say it rounding. But we don't just round the mathematical way, the way you have been taught that always when you have 12,56, the answer, if you want to round to one decimal, the answer will be 13. That's we call knowing this. Yes. But in mathematical literacy, before we can round, ladies and gentlemen, boys and girls, my honorable grade 12s, we take care of what, Mr. Chabalala? We take care of the what? The context. And Dr. Chabalala, now you are coming with another bombastic word. What is context? We take consideration of the what? The scenario. What is the scenario, Mr. Chabalala? An example is that when we are dealing with, let's say you want to buy tiles that are going to fit or are going to be used in a room. How will you round? Remember, rounding, it's either up, sorry for that. I need to go back. Okay, I touched on that one. Remember, rounding is all about up or down. So, when we are rounding in terms of tiling, what is the context? The context is tiling. The scenario is tiling. I've made my calculations and I found out that for me to tile this room that I'm inside, or the classroom that you are inside as we speak now, you are going to need 347, 25 tiles. That is the quantity. Now, when you are doing the calculations, can you go to the shop and say, or CTM or whatever, the place that sells the tiles, and say, hey, I'm going to buy 347,25 tiles? They will look at you and say, sir, ma'am, are you okay? Yeah, no, this is what the calculator gave me as I was calculating. No, they will say to you, no, it's fine. We don't have a 0.25 of a tile because a tile, it comes like this, solid. Yes, we can cut it and we understand. But in this case, we don't sell the tiles in halves. You understand? Or in 0.25s, whatever. So we sell it as a round figure in terms of quantity. So tell me, are you going to round it up or round it down? Are you going to say, in this case, I'm going to buy 347 tiles because this number after comma is less than 5. And I was taught that if a number is less than 5 after comma, I'm rounding down. This one becomes for a 7. Or you're going to say, I'm going to buy 348 tiles. What are you going to do? I made my screen to be smaller. Or was I press yes? Mr. Max? Yeah. Okay. Thank you. Now, remember, I was on this. I want to check whether my PowerPoint is still there. Yes. Sorry for that. Sorry for that. Yes. Good. Now, you are going to say 347 or 348. Oh, you have already answered. 348 tiles. I'll buy 348 tiles. I will round up because the scenario, in this case, the context, it's all about tiling. It's all about tiling. If I can buy 347 tiles, what is going to happen? The person who's going to tile, he's going, yes, you are right, you are right. I bought 348 tiles because if I can buy 347, I'm going to run short of tiles. I rather buy more, one or even if 2 or 3, so that. And what are the other reasons of buying more? It's because I might have some other tiles that are breaking. So it is important that I buy more because we are talking about tiles. The context is tiles. You understand? Now, we take a different scenario. Let's say you are going to, I want to make an example with the practical one. You are going to buy boxes of whatever, and you have a bakkie or a van, the way you know it. And you know very well that your van, the back of your van, can put about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, about 12 boxes. And you do your calculation, and your calculation says buy 12.5 boxes. In this case, are you going to say, I am buying 13 boxes? I'm rounding up. And you are very far. You can't come for the second time. You need to buy once. No, you can't take 13 years. Why? Because the 13th one was not going to fit into that. So in this case, even if it is more than 1, 5, or it is 5 after comma, you are not going to round up. You are going to round down in this case. Why are we rounding down, Mr. Chavala? We are rounding down because we are focusing on the what now? In terms of fitting, whether it will fit. And the context here is all about fitting, whether how many boxes can fit inside this parking. In this case, it was all about not so much for fitting as such. It's about need, whether I will really, will they be sufficient in terms of buying or enough? You get a point? So we round according to context. Now, in this case of packaging, Today we are dealing with packaging. You will see the grade 12s that most of the time, or at all times, it's all about fitting. Can these cans fit in this box? Can this box fit in another box? So when you are dealing with fitting items, you are rounding down. You are always rounding down. Irrespective whether your calculation is 12,9, the answer will be 12. Because if you can go to 13, it's not going to fit the 13th one. I've got a big student here of mine, an IT one. I want to convert him from maths to maths lead because this is practical. Yes. So it is very important that you understand that before we come to the examples. When analyzing the best packaging arrangement and materials, keep in mind the following. I must respect time. I think maybe I was thinking that maybe you still have a lot of time, but this time flies. Remember, I spoke about terminology. Remember, your teacher gave you a classwork about the terminology. So this topic of the models of packaging, it has its own terminology. You must know what is the two-dimensional models. Someone say, hey, Mr. Chawala, Mr. Chawala said it earlier. Hey, this guy, hey, I'm not the guy, I'm the teacher. 2D model, 3D models. No, it didn't work because the question will ask you, explain for 2 marks, what is a 2D model? Model of a real object drawn to scale that shows only length. What is important is to see that, remember, we spoke about 2 dimensions. If you can just say it shows length and breadth, you get your full marks. 3D models. Model real object drawn to scale that shows, even if you don't say drawn to scale, doesn't matter. As long as you can say it has the length, the width, and the height. You remember, this one comes from length multiplied by length. It will be square meters, centimeters squared. Remember, millimeters squared. I was making even example. There 2 shows 2D. Here it's meters multiplied by meters multiplied by meters. It will give you what? Cubic meters. So, to the power 3. M to the power 3. So that's why we have 3D. What is packaging? Process of packing items into a limited space like a box, suitcase, cardboard. But it's all about fitting so that those items can fit. What is a packing arrangement? Spoken about that. Models showing different ways in which items are arranged. Remember which are those? Yes, you are well listening, boy. Practical and mathematical. Which one are we going to use in MathLead? We are going to use practical method. The most appropriate way of packaging that uses minimum amount of space to package the maximum numbers of items. That is this one. Most cost-effective way of packaging arrangement that uses minimum amount. This is where we focus more. We want to save money, but we want to package a lot of items. That is the most cost-effective way of packaging. Height, the scale, determine many times wall of object shown, blah, blah. It's not going to apply a lot. Number, scale, blah, blah. Scale, thrown, floor plan. Okay, this is for the other topic. Don't worry about that one. Examples. That question that I found. Height. Leo must pack chalk boxes on a shelf in Mrs. Machoba's classroom. The chalk boxes look as follows. You know that you once saw this box. You see, MathLead is practical. In your class, your teacher comes with this and put it on that, and he said, you must tell other teachers not to steal my chalk. So, but we are not focusing on the chalks inside. We are focusing on the container, which is the box. Packing chalk boxes on a shelf. The chalk boxes looks as follows. Let's look at the shelf or the table. Right. Now this is just a box, but we are showing you the longest side, which is the length, and it is 7 centimeters. And we are showing you that shelf. Here is the shelf. Start here, it ends here. What is the question? How many boxes will fit on top of the table? It's a box vis-a-vis a table. All right? This box, it is in a rectangle form. Even the table is in a rectangular shape. So it's rectangle vis-a-vis the rectangle here. Now, which method are we using? We are going to use the practical method. The practical method is to take the length of the box over the length of the chalk box. So we are modeling it in such a way that we are going to put length on top of the length and count how many will fit here. So we are doing it in the way we are taught is that if you want to see how many boxes are going to fit, you are going to take the length of the table, which is 120 centimeters. Here it is given. You divide by the length of the box. What is the length of the box? It's 7 centimeters. Here is 7 centimeters. You just press your calculator and say 120 divided by 7. It gives you 17,1428, blah, 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 blah. So I didn't write everything. If this was 3 marks, let me show you. Maybe the marks will be saying, for substitution here, substituting 120, substituting 7 centimeters, 1 mark, 1 mark. And 1 mark for the answer. Why, Mr. Chawala, there's no mark for this? No, because this is not the final answer. You have not answered the question. How many boxes? We don't have comma boxes. Box is a discrete number. Remember, in data handling, it's not a continuous one. So we need a whole number. So in this case, you got 17,1428. It's all about fitting. How many can fit? How many boxes can fit? Mr. Chairman said, when we are dealing with fitting, the context is fitting. Are we rounding up or down? Yes, we are rounding down. So in this case, 17,1428, when you round it down, it's going to be 17. Meaning that the number of boxes that are going to fit on this shelf will be 70. Can you see that? Even if the answer was 17,678, we're not going to say, here is after 5, it's a number which is bigger than 5. As a result, the answer is 18. Mathematically, so yes, you can say this is how we're going to. But here, the context is different. It's all about fitting. The 18 boxes cannot fit. The other one is going to leave a space or protrude outside. So it is very important that you understand that we are dealing with the fitting, hence we round them. Right. There is a question that says, Why I am not allowed to measure box using my ruler and draw number of boxes that can fill using my ruler, that can fill using my ruler. Right. Oh, it's a wonderful question, this one. In real life, you will do that. But here, remember, it's all about writing on a pen and a paper. So as a result, you can't remember the issue of the scale. What you see here, this 7 centimeter, at times is not the real one. Now, if you want to, the question most of the time, don't say to you, measure. It says to you, the size is already 7 centimeter. So why do you stress yourself that you want to measure? We only measure there in the questions of the maps. But here we are dealing with just calculations and coming up with the answer based on a context. So there's nothing wrong when you are doing there. In a real life, you say, okay, so let me measure and see how many can fit on that one. But in this case, you don't have to, because already it's given to you that the box is 77 centimeter. It is already given to you that the length of the table is 120. What you need to do is to use your skill, that if I want to get the quantity as to how many, I just take the length over length. We are going to say, normally, with our language of math, we say you are using a lengthwise method here because you are dealing with a length over length. Hey, nice there. This is lengthwise. So you just substitute what is given to you and just get your answer. You don't need to measure. Thank you very much. It's a good question. All right. Now, did you understand that one? It's a smaller one. That one is a simple one. This one, I was just giving you the basic here. This can also be done in grade 10. But I was just reminding you. Because what we are going to do, we are not going to focus only on calculating a box sitting only one side. Here we are going to look at multiple sides of a box going forward in grade 12. Now, Mr. Chabalala, I want to do this one again. Still the basics. There are 2 shelves in Ms. Toko's classroom. She asked Leo to pack on the second shelf some open cans in which she can put pens and pencil. The cans look as follows. Again here, it's all about the shelf, which is a table which has a length. And this time, it is all about the can. Here is the can of the pencils. We are not focusing on the pencil. We are focusing on the holder of the pencil, which is in a what? It is in a circular shape. And the moment you see circular, circle, what comes to your mind? Radius, diameter. You understand? When you see something that is rectangular, you think about the length, the breadth, and the height. So in this case, we are picking what? It's a rectangular vis-a-vis, Mr. Chabalala, versus what? A circle or a circular shape. So, or a cylinder. This is a cylinder. So in this case, let's check. We want to see how many, still the same shelf or the same table, but in this case, we are not picking the boxes of chalk. We are picking what? This pencil holder. So, and it is in a circular shape. But we need to understand the part that this can is going to sit on the table. How is it? It is circular. But that circular, it has a straight line which touches, move from one circumference to another. What do we call that line? That line that divides the circle into 2 equal parts, it is called a what? A diameter. A line that passes through the center of the circle and moves from one circumference to another, it is called a diameter. So This is what we are going to use to check as to how many what you call cans will be able to sit on the shelf. So we are going to take the length, which is the diameter of this particular can, over the length of the shelf. The same thing that we did, I remember now with the, I want my notation that I don't want to go out. Oh, they have moved. Thank you. Why they are not moving now? What? Thank you very much, Mr. Max. How many pencil cans will fit on top of the table? That is the question. Sorry for that. A number of pencil cans is the length of a table, which is how much? 120. Over the diameter of a pencil can, which is going to be 5 centimeter. You divide the two, you get 21,8181. What a nice example, this one. Rounding up or down? Down. 21,81, when you round it down, goes to 21. 21 pencil cans will be able to fit here. So there'll be 21 all in all. 21 all in all. You can't say 22 because you had 8 here. It's not gonna fit. The 20, if you say 22, you can't say 22 because once you say 22, the other part is going to fall out. You see, it's not gonna fit. We're dealing with the what? Fitting. Does it make sense? Wonderful. Now we move. I hope you are following me. Let's do the real now activities. Packing sandwiches boxes. The sandwich boxes in a rectangular prism. Now, in this case, this person has got this business of packaging these boxes of this sandwich pack, which is in this form. They must come inside this box. Now we need to check as to, or calculate as to how many of these can fit into this big box. Smaller box of sandwiches inside the bigger box of the sandwiches that need to be packed. And we have the dimensions for both shapes or items. But before we continue, what you see is being different. The shapes are the same. Yes, it's a rectangular prism, and this one is a rectangular prism. Also, they're the same. But what is different in terms of the dimensions? Yes, John, you are right. Millimeters. The dimensions of the sandwich pack is given in millimeters. Whilst the dimensions of the big box or the carton of sandwich, it is given in centimeters. Remember, we are dealing with what? This topic is all under measurement. And your teachers always talk about what? Conversions. And that's where you're losing marks, even in the exam. You are in hurry to calculate without making sense of the question. Oh, Tito, you can't. No. Ngizoyishaya life-wise, length-wise over length, length over length, breadth over breadth. I'm just going to say 94.6 divided by 110, 58 divided by 110, 36 divided by 30. Ngishayile man. I have full marks. What's my name? Then you ask your friend after the exam, hey, in fact, we only 5.5. Yeah, the answer is so much because you just have to divide the two. And you just hear a person laughing. Why are you laughing? No, Anthony. No, man, you can't just rush. And you haven't seen that the dimensions are not the same. Eh? You are supposed to have converted one of the dimensions to be the same before you can divide. Eish! Ebla ngizobona ne sharp. Mawufika ekhaya walala. You sleep, go straight to bed. Don't even talk to anyone. You killed yourself, you shot yourself by doing silly mistakes. So let us take care of things like that. Remember, you dealt with the conventions long time ago, but here we are applying it here. You can't separate the topics. They go together. Mathlet is like a network or a chain. So it is very important that you take care of that. Now, my advice is that always take the dimensions, leave the dimensions of this one, of the bigger box as they are, and try to move the millimeters to what? To centimeters. Am I right? I won't waste time on this because you know the skill. What we know that is that 110 millimeter is the same as 11 centimeter. 30 millimeters is the same as how much? 3 centimeters. Which slide is that one? It's this one. Yeah. Now, what is happening in this case? I'm just converting the dimensions of the sandwich pen. The 110, this side is 110, which is the length. Let us not forget, this is the length, this is the breadth or the width. And this one can still be a length, doesn't matter. Doesn't matter because they are the same. Now this one is a what? It's a height, which is 13. It's the same as how much? 3 centimeters. And here I've just divided by 10, divided by 10, divided by 10. You move from millimeters to centimeters. Am I right? Wonderful. Now, you have the new dimensions. The new dimensions is that the length here is going to be 11 centimeters. And here, the length of the breadth, whatever you call it, is going to be 11 centimeters. And also here, the new dimension for the height, let me write it here, is going to be 3 centimeters. I know that you are done already here because you are fast. I'm old. So you have already found an answer. Let's work now the solution. With the solution. Okay. What will be the solution? The solution, Mr. Chabalala, is that we are going to use which method? The practical method. You don't have to write it in exam. I'm just saying to you so that you can remember that always we are using practical method. So we start with the lengthwise. We're going to deal with lengthwise. We are going to take a length divided by length, breadth divided by breadth, height divided by height. But it is very important to know that you're going to do what? on top, your numerator will be the bigger one, and here is going to be the smaller one. If it's a length, it's going to be the length of the bigger box over the length of the smaller box. That one must be known. Breadth-wise, lastly, height-wise. Sisonke. Okay, what will be the length of the bigger box? It's 94,6. We all agree. We are going to say, or let's write it nicely, length of the box or the cartoon. They call it a cartoon. Over the length of sandwich box or pack. And we substitute 94, yes, you are right, comma 6 centimeter over, you are right, 11 centimeter. What is the answer there? Give me the answer. You come to the what? You came to the breadth-wise of box or cartoon over the breadth of a sandwich box, which is gonna be how much? Yes, 58 centimeter over what? Yes, 11 centimeter. Remember, they are the same. Then you go to the height. Or cartoon over the breadth of the sandwich. It's gonna be how much? Not the breadth, Mr. Chabalala. Hey, wake up. Pen, height. All right, which is gonna be 36 over what? 3. Good. I've got answers in the next slide. Then we move to save time. I want to check your answers. I know you've got answers already. Wonderful. Practical particle method of quality. Right. 94 divided by 11, 8,6. Round it down, 8. Meaning that along the length of these cartoon of sandwiches, 8 sandwich packs will sit down there. Now let's check on the width-wise. How many will sit? The part of it. Meaning that the side of the width of the sandwich, how many will fit on the width of the bigger box? 58 divided by 11, 5,27. Rounding up or down? Down. When we round 5,27, the answer becomes 5. The last one, height-wise, height over height. That was 36 over 3, which is equals to 12. Where did I take 30 from? Oh, I made a mistake there. When I was, let me check. I think I wrote. Oh, no, it is still 36. Okay. There we are. Okay. Now we have 8 multiply. We have 8, 5, and 12. Why did I make it bigger and I didn't make? Okay. Doesn't matter. We have now, in this case, we found that Sorry for that. I want my annotation here. Okay. Right. Now, we found that we have 8, 5, and 12. So in this case, your final answer will only come by taking the 3 sides or dimensions and multiply them to get the total number of items or sandwiches boxes that will fit in the bigger box. We are taking now your 8, your 5, your 12. It's 8 multiplied by 5 multiplied by 12 is equals to 480. That makes see, I've maximized it. I want to go back. I don't know what I did. Now, number of boxes that will fit will be 8 multiplied by 5 multiplied by 12. So, yes, thank you very much. So now in this case, we have found out that for inside this box, you can pack how many sandwich boxes? 480. Your boss will be happy. So you see, that's a lot. It's a lot. And you find that it costs only 50 rand per box. So you have saved because now you have paid a lot with a little amount. So you are cost effective. On the other side, you ensure that you pack as many as possible. Okay, if you have any questions, you'll write it for me. But now I continue. I hope you understood it. This is the very crucial example because this is the way you're supposed to do it in an exam. But on this one, be careful of the dimensions. Check the units. Check that is it meters versus millimeters or centimeters versus millimeters, like in our case, and convert before. So it is very important that you take note of that. Just one other thing that I want to show you, because we are dealing with quantity here. You see, I wrote centimeter over centimeters. Mathematically, they will just cancel each other. Then you are left with the number. So doesn't matter. Even when you substitute, you can only substitute the values because we are looking for the quantity. Like on this solution of mine, you can see I just have 8 by 5 by 12. That's what I have there. All right. Are we together? Okay. But I think my slides are not all there. Let's give it. All right. We are very close to finishing the lessons of the day, but I just want to check if I have one more example. It will be proper that I give you also the one where we are taking a rectangular, what you call a cylinder inside the box. Definitely, I hope you will like to have that. Let me just put it in there. Okay. For rectangular prism, vis-a-vis rectangular prism, do we have any questions on that one? If you have a question, you can write it for me. Mr. Max will give it to me here. All right. So your mics are open. Any questions? Any questions? Oh, Mr. Chawala was clear.
Okay, sir. I have a question.
Okay. What's your name? What is your name, my girl?
Sinoxolo Mdike.
Ah, Sino, what's your question?
Okay, cela ubuza ba. Okay. Xa ufuna umosi ezi number of boxes ne utshintsha item leyo ifuna uyifaka eboxini i-units.
Yes.
Utshintsha
Yes.
ezi zale nto ifuna uyifaka eboxini.
Okay. So in this case, you can still change. You go for the one that you think you're not gonna be complicated for you, yeah? So
Yes, sir.
you saw that it was millimeters vis-a-vis centimeters. So you born it? Yeah.
Yes, sir.
Yeah. So I decided to take what? The millimeters and make them what? The centimeters. Because the bigger box was in centimeter. You understand? So
Yes, sir.
I found it easy if I take the measurement of the bigger ones and make it the what you call of the smaller one and make it to be the same with the bigger one. So the sandwich pack was in millimeter, and the ones of the box, the big box where the sandwich is going to be packed inside, was in centimeters. So normally we will take the ones of the bigger box and leave it as it is, but the one of the smaller one and change it. Or understand?
Yes, yes, sir. Thank
Yes.
you.
So what is important when I sinoxolo ukuthi ufanele ukuthi you must remember your conversions rate. How do you move from millimeters to centimeters? How do you move from centimeter to meters? Wakhumbula ke, ne?
Yes, sir.
All right. Thank you, my
Can we
girl.
have a classwork?
No, let me do another one. Let me do another
We want
activity.
some homework.
Yes, the homework. The homework, I'll send the
Yes.
homework. Or I'll give it to you. But let's do this one. If there is any other questions before I continue. All right, let's do this one. Sino, and you can close. Okay, Bob makes you can close their mic.
Okay, another question.
Oh,
Okay.
Yebo. Yes.
Okay, so okay, class no 8, mhlawumbe 8,6 ne.
Yes.
Asifumene ku lengthwise. Why singa round up si round down?
Bolalele kahle my presentation before ngiyenze example ukuthi ngitheni rounding up and rounding up. Miss Mjali? Miss Mjali?
Anif angumtshali wethu lo mtshali.
Ubani?
Sinoxolo la. Sinoxolo
Oh.
here.
Oh, Snowball. In this case, when we are dealing with it, I guess it's fun. We want to know ukuthi how many will fit, ne?
Yes.
So when you are dealing with fit, you can't round up because when you round up, if it was 8,6, you can't say the answer is gonna be 9 because the ninth one ngeke fit inside.
Okay.
You understand? And you can't cut it out. That's why we are going down. We say instead of 9, let's make it 8. Ukuthi fanele ukuthi ifit inside.
Yes.
Yes. And your friends there, I can see what they understand and they can even explain to you further. But when we are dealing with packaging, we are rounding down most of the time, okay?
Yes.
Because we are dealing with fitting inside. Yeah. Yeah. But if you are buying, like let me make example. Let's say you are calculating the number of people who are going to take Sinokolo Lalela.
Yes,
Don't make
understand.
noise. If you are going to use a quantum, you are taking a trip and you have calculated how many people are going to fit in the quantum. Quantum takes 15 people.
Yes.
So, and you calculate and you find the number of people that can fit is 15,5. 15,5. Will you say the answer is 16? 16 people must go into the quantum. Will they fit? They won't fit. So as a result, you round down because it's all about fitting the people. You can't have 15,5 people. It's either you have 15 or 16. But in the case of a quantum, you can't have 16 people. They won't fit. It will be overload and the driver will be arrested when the traffic officials stop the car. All right, let me continue. Thank you very much, Nyokolo, and your friend there, and for asking a question. Now, where we are, the last one that I want to do is this one of rectangular prism versus the cylinder. Remember, I said tins can be fit in the box that is rectangular, but a tin is a cylinder. If you remember very well, a tin is a cylinder. Now, if a tin is a cylinder, it can fit inside a box, and we can use the practical method again to calculate as to how many tins of whatever can fit in this. In this question, the information given is this. And it's very important when you are writing exam, read the given information. Don't rush to the questions without understanding the context or the scenario. A company that manufactures cat food, ukudla, cat food, TJ's, I mean the name of the company, packs the cat food in the boxes and they are then delivered to different shops around the country. An image of the cat eating food is given, is this one. Let's call it figure A. Is given below with the following dimensions. The diameter of this tin is 6 centimeter. Here it is given to you. And the height is 4 centimeters. Now, the question says, use the mathematical method to determine the number of cans that can be packed in a box, one stacked on top of the other. What are they meaning? They mean that on the bigger box, these cans will be sitting on top of each other. Omunye phezu komunye. Now, this is exactly the way they are going to be packed. They are giving an example. We are modeling something like that. So, in this case, you need to calculate as to how many. Now, the question says, use the mathematical method to determine the number of cans can be packed in a box. Remember, I said to you, we are not going to use the mathematical method. I don't even want to waste your time. I will go straight to, all right, let me just tell you why are they saying mathematical method? They are saying mathematical method is that one where you are going to calculate the volume of this cylinder and the volume of the rectangular prism, and you divide, and it's not going to be correct. We don't want to use that one. So this one, we are not going to use it. So we are going to focus on use the practical method. We are going to use the practical method. I don't want to use a mathematical method. Remember, I told you. And the next question says, why there is a difference between the practical method and I won't even go there. I don't want to waste your time because we want to pass at the end of the day. Now let's go to the solution, right? Okay. All right. I forgot to mention that The dimensions of the bigger box is 51 centimeters, 33 centimeters, 43 centimeters. Before I continue with the solution, for this one is nice because the dimensions are the same, centimeters vis-a-vis centimeters. I don't have to convert anything. I hope it must not is that you cannot change any dimensions because they are the same. So you just go straight and divide. What will be the solution in this case? The solution in this case is that again, it's a practical method. We're gonna go, in this case, remember we have a diameter here. It's not gonna be the length over length, but this diameter, we can take it as a length of this particular can. So in this case, it's 6 centimeter from here to here, meaning that it's 6 centimeter from here to here. And now this is going to sit like this in a circular shape. So you see, we are going to take the diameter, we divide it. We're going to take the length of the box and divide by what? By the diameter of the can, and see how many diameters will sit here. You understand? So it is very important. Then after that, we are going to take the height. This is the height. Remember, they said omunye phezu komunye must be packed height-wise also, meaning that we want to see how many on the height they will fit. And again, this way, how many will fit there. Remember the can also now, we are also going to focus on the breadth of the bigger box vis-a-vis still the diameter, because this can, it is like this, and this will sit on the length and it will also sit on the breadth of the box. Okay, let's follow. We are going to say, in terms of the length of the bigger box, we can still call it lengthwise. Then when we say lengthwise, what is the dimension of the length of the box? Remember, we said the bigger one first. It's gonna be 51 centimeter over the length, in this case, of the can is the diameter, which is 6. Right? We are going to get the answer. Then we go breadth-wise of the bigger box. We are going to take the breadth of the bigger box, which is, in this case, 43. We divide by still 6. Right? Because it is sitting in a diameter form. Lastly, height-wise, which is gonna be, the height is 33 of the bigger box over the height of the can, which is 4. I hope you are pressing the calculator and get what is the answer. Now, let's get the answer for the first one. 51 divided by 6 is equals to 8,5. Round up or down? Down, Mr. Chavala. 8. 43 divided by 6 is equals to how much? 7,166. I converted, I rounded down also. 7. 33 divided by 4. 8,25. Round it down because it's all about 58. You're not done. This question can be 6 marks, can be 7 marks. Already, you'll be having how much? Let's say 2 marks. 1 for the answer here, final one on this line for substituting. 1 mark for substituting. Final answer here, 1 mark. 1 mark. How many already? How many marks? 6. Huh? But you are not done. You're not done. So you say number of, you write it nicely. You must be smart in the exam. Number of cans will be, that can fit, that can fit in a box. That will be 8 multiplied by 7 multiplied by 8. Remember I said for you to get the final answer, the total number, you multiply all these three. What you call the answers that you get from the length, from the breadth, and from the height. You multiply the 3 of them, then you get your answer. It's going to be 8 multiplied by 7 multiplied by 8 is going to be 448 cans will fit. And that can be another mark. So this can be 7 marks. Just imagine. For one question, 7 marks already out of 150. Remember, you answered question 1, you got that 30 marks or 28 already. We are passing along. We are very close. But only if you can practice and understand. If you don't understand, go to your teacher, assist you. So in this case, we were dealing with what? The rectangular prism vis-a-vis the what? The cylinder. One mistake that you are doing, you stop here. You haven't answered the question. Because we are dealing with fitting. How many can fit? And you can't stop here without giving us. We don't have half of a can. You can't cut it. You can't say it's 8,5 is an answer. No, it must be a whole number. It's either 8 or 9. But you can't say 9 because 9 won't fit. We are rounding down. I don't know how many times have I mentioned the issue of fitting, rounding down. So a proper tonight, you're going to I'm fitting, if you can fit, rounding down. That's what I want. I want you to, it must sink until even you dream about it. And tell mom or your dad, no, don't worry. It's all about packaging. I'm dreaming about packaging because that Shabalala said, I must master this skill. So I hope you understood this part of what you call packaging the cans inside the box. I will check for you. I will talk with Mr. Max here. I will give him an exercise or a question that you can practice with, because I was not called or they were saying, hey, we are ready for the homework. It means that you were listening. So there are a lot of examples that we can make, but I don't want to bombard you with a lot of examples. What is important, even one example, if you have understood it, you can use that understanding and the knowledge and answer any question that can come. Remember where we started. Very important that you understand why packaging and where do we use it in real life situation. So in those words, I want to thank you very much. We still have other activities that you can do, but I want to pause here because even a triangular shape can still fit in a box also. But now let's go and practice these two. I will ensure that you get the other activities so that you can push on yourself. Having said so, thank you very much. You're a very nice audience. I hope you enjoyed the lesson, and we are going to meet again next week, Saturday. Thank you. Any question?
Teachers naye.
Ubani?
Sinoxolo here.
Nokolo.
Sinoxolo here. Yes.
Nokolo. It's you again. You really enjoyed this one. Come, my girl.
Okay.
What is your question?
Okay. Cela ukubuza uba. Okay. Uzwazi lapha kufunwa AP into yabo. Xa kuthiwa mathi umbuzo kanje uba determine the number of layers of can that can be placed in an upright portion of the box yabo. Ba kuthiwa nga-upright na kwavele kwathulwa uzoyazi lapha kufunwa AP into.
On a layer. Mr. Mickett, you know what? Can you go back to my presentation? Try this one. Yeah. The one that I finished with. Yeah, just this one. Okay, Sino,
Yes.
I have one activity here. I think it can answer your question. This one. How many layers? You see this one?
Yes.
Yeah. You see this one? It says to you, there is a okay, the first one, it was just to calculate the volume of the box here. Don't worry about it. But let's say you have this box, here is a shelf. And on that shelf, you want to see how many layers of this box can sit on this shelf. Isikatulo zakho ne? You want to pack them. You understand?
Yes.
Let's check here. You are given that the height of this shelf is 118. Yeah?
Yes.
And the height of this box is how much? It's not given to you.
11,9.
11,9. Yes,
Nine.
it's 11,9. How many layers of this box can fit on the shelf? How are you going to get it?
118 centimeters.
So you can say number of layers will be equals to 118 centimeters. Yes, over divide
11,9 centimeters.
11,9 centimeter, my girls. Right? Then press your calculator.
9,91.
9,91 layers or boxes that can fit. Now, am I done here? Is this the answer?
No.
No, it's
No.
not an answer because the calculator gave me 9,91. Why? What must I do?
Round
Huh?
We round down.
We are rounding?
Down.
We round down even if it is 9,9. Why are we not going to 10? Why are we not going to 10?
Because ayizibonela enye. It won't fit.
Aha, that's what I want, my girl. It won't fit. So, meaning that you are listening very well. It means that the answer will be 9.
9.
Meaning that in that shelf, only 9 layers will fit in that, what you call shelf.
Meaning, xa kufunwa into, layers sojonga height wise.
Yes, it will depend if it even is. Let's say it was even the cans. Let's say how many cans can fit there, and you are given that this 5,2 centimeter. This is the height. You are still going to do what? To take that 118,
Height.
but this time divide by the height of the can. You understand? And you continue and you get the answer. Those are the layers on top of each other. Omunye phezu komunye. Right? Are you fine? Are you answered?
Yes.
Yeah. So you forced me to go to the next activity, which was very good. You are a prophet, and we have helped others a lot also. So because I wanted to pause so that I should not come back. So thank you very much. Thank you very much. Any other question?
No, thank you.
Okay. Thank you very much. Let's close. Let's see each other next week again. Sit at 1 o'clock, and Mr. Chawalala will tell you what is gonna happen. But I think I'm gonna do something again that is going to be done. That has been done in term 3. A topic like the assembly diagram or even the elevation plans. So be ready, enjoy mathematical literacy. It's a nice subject. You must all pass. Bye-bye.